Hello everyone, welcome to 100 Days 100 DSA Problems series where we are going to solve one DSA problem every day. So today is day one, which is maximum subarray problem. So the problem statement for this question is, so we will be given an array of integers. So it could be -1, -3, 1, 4 and -5. So our goal is to find a subarray from this array. For example, this is a subarray which contains maximum sum. That means whenever you add the elements of this subarray, you need to get the maximum sum out of all possible subarrays. So even for example, -1 itself is a subarray, or you can take the entire array. So every array is a subarray of itself. So before going into solution, output requirements are that we need to give the starting and ending indices of the subarray. So for example, in this subarray, if the solution is this, I need to give the index of this number and index of this number. So it will, we can say it's the starting index and it's the ending index. Okay, and the sum itself, like we need to give the sum. So here in this case, the output will be sum is 5, which is 1 plus 4, and index would be 2 as a starting index and 3 as the ending index. Okay, so let us see like what's the solution for this problem looks like. Uh, Consider this case. For example, our array might contain all positive integers, right? So here the solution is very easy. Why? Because if someone says you, I'm only going to give you arrays with positive integers, you will directly say the starting index would be the leftmost index, which is 0, and ending index would be the rightmost index, which is 4. And the sum would be sum of, for example, if this array is A, sum of all elements. Why? Because if every element is a positive element, so obviously you don't need to consider any small arrays out of this. You can give entire array as the answer. Because if I add everything, it would be much bigger than if, for example, if I am not considering 5, right? So that would be the easiest solution for it. But in our case, it's saying array of integers. So we will have negative integers also. So for example, -3, 4, 5. So here you can't directly say ki, and if you sum everything, you will have -3 in between and you will get less number of, the solution would be less, right? So for example, take this case, 4 plus 5, how much? 9. 2 plus 1, 3. So if I take this subarray, I will get 9. If I take this subarray, I will get 3. If I take the entire array, how much I will get? -3 and +3 gets cancelled. Answer is again 9. So the solution could be either 4 comma 5, or in this case you can take full array as a subarray also. So both of them are solutions. But for our question, assume there will be only one subarray which has the maximum sum. Okay. So before solving this question, you need to ask the interviewer whether this criteria needs to be handled or not. Okay. Next, it's not simple ki you will directly start the loop from here, and whenever you face negative number, you will say this is the maximum subarray, because there might be bigger numbers on the right side also. So you need to consider that case. So obviously for any problem, there would be a brute force solution, right? So to find brute force solution, it's always easy to just go to question itself. What is it saying? Of the subarray that yields the maximum sum, right? So why not find all the subarrays that are possible for a given array and sum for each and maintain a global sum and compare each subarray sum to global sum. Whenever I find sum which is greater than global sum, I will say that would be my global sum. For example, for now, whatever the calculation I have done for previous subarrays, maximum one is 9. Okay. Next, I went to next subarray. I got the sum of this subarray is 10. So I will update the maximum to 10 and give indices of this subarray as the solution indices. Okay. By this way, we will cover the entire array and possible subarrays and give the solution. So that is what the brute force solution for this problem is. So before even going into the exact solution, we can simply say that, right? For example, we have an array. How would I get all possible subarrays? It's just we'll start from starting index. There would be a for loop, which is for starting index. And there would be another inner for loop, which loops from whatever the starting index to next element. So it would be the to find end index for this subarray. So let us take this case. Initially, consider it as I. Here it would be j. Okay. So I is equal to 0, j is equal to 0. What we will do for I is equal to 0, we will come to j. So j will start with I. Okay. Whenever I is 0, j will be 0. If I is starting from here, that is 1, j will be starting from here itself. So why we are starting from here itself? Because there could be single element subarrays also. So first, what would be the case? First subarray would be I is equal to 0, j is equal to 0, which is 1. Next, in same I, like for 0, j will go to 1, right? So j will now go to this particular number, which would be subarray of 1, comma 2. Next, for I being 0, j can move to this index. So it would be subarray of 1, 2, minus 3. So like this, we will cover everything. So first loop for I will end where? Once j covers entire subarray and we will get this particular subarray, which is the full array, right? Now, because we have completed this particular array, now we will increment I to 1 again. So I plus 1. Now I will start here because initially it used to be here 0. Now we are plus adding 1. So I will start here. So first subarray would be 2. Now j will again move to here. Next subarray would be 2 minus 3. So like this, it will cover all the possible subarrays. Next, again, I would come here. J will cover these subarrays. Like I would come here. J will cover these subarrays. Then I would come here. J would be also here. That is 4 comma 4, right? For I comma j. So it will cover this subarray, which is only 5. Like this, we will move to every possible subarray and calculate sum of each subarray. And if this and maintain a global sum also, which will be the maximum sum that we have found till now. So estimate sum x. So we'll compare this x with every sum of subarray. And if this sum of subarray is greater than global one, that is, if subarray sum is greater than global, we will say global is equal to subarray sum. So we'll be updating global with subarray sum. So this is the easiest solution. Let us see the concrete code for it. Okay. So as I mentioned, what we need to do, we need to maintain a variable which is the maxsum. That is maxsum till now. So you might ask this question why it is minus infinite float. So we are going to compare this maxsum with the subarray sum, right? So what's the comparison metric? So if subarray sum greater than maxsum, right? So take this case, minus 1, 2 is our array. What is the first subarray? It is minus 1, right? So what is sum of minus 1? It's just minus 1. If you compare this with this, assume I am not using this and using 0 as the max sum, initial sum. What happens? Minus 1 is less than 0, right? So I will not be updating my global variable with -1. Again, with this case also, if we, even if it comes to -1 plus -3, it's -2, it's -3. Again, we will compare with 0. And as you know, 0 is bigger than this. Our solution says 0 is the maximum. But we know in this case, assuming there is no option of giving empty arrays, which are considered zeros, we need to give arrays which have minimum one element, then our max sum would be -1 because these are negative numbers, right? But our solution, it's saying 0. So that's why we need to maintain something in this initial maximum, global maximum, which has the least number possible. So any comparison will work because now we have exactly seen why 0 would not work. So we are giving minus infinity, which is a value in Python which represents minus infinity, or in this case, it's the least possible value for this integer. Okay, so there is no number that you can declare which would be smaller or less than this. That's why we are saying we are initializing maximum with minus infinity. Next, we have just talked about it, right? We need to maintain start index and end index of that subarray. So, for example, 1, -1, 4, 5. My max subarray would be this, assume. So, I need to give the output key. My max subarray starts from 0, 1 to second index and ends at third index, and the sum is 9. Okay. So, as I mentioned here, you need to take the assumption or ask the interviewer himself or herself that if there are more than one max subarrays, what should I do? So either they will say they'll be giving, you need to provide both the subarrays, or you need to only provide one subarray. So for this question, assume there would be unique max subarray. Okay, here it's 4, 5. Even if you consider this entire array, it's also adds to 9. So this can also be the solution, but depending on our own algorithm, we will be giving only one as the solution. Okay. Now, as you know, we know there should be two for loops, which should loop from starting index to end index and form the possible subarrays. So that's what we are doing. So there are two for loops, and first loop I is starting from 0 to length of array. That means till -1 included. Okay, and j starts from wherever I is there. For example, in this case, I is here, then j starts from here. If I is here, j starts from here. Okay, so there is a local or in loop variable, okay, which maintain whatever is the current sum, because we need to know what's the current sum for the subarray we are forming, right? So that's the current sum. What it does for each subarray, it adds, for example, in this case, take this example, -1, 2, 3, 5. So we will start with 0 for the outer for loop, and inner for loop will be 0. So let us see, yeah. So now inner for loop would be 0. So what would be the value of current sum? Whatever the element is present at array of j. So which is nothing but 0th index, which is -1. So current sum is -1. Right. Now you need to check. This check needs to always happen. Whenever current sum is greater than maximum, we need to update the maximum. Otherwise, we will not be able to maintain the largest maximum. Okay. So, and also we need to update the start index and end index also. So, for example, in initially, what would be the value of start index and end index? Because our maximum is minus infinity. So, -1, which is the current sum, would be obviously greater than minus infinity, right? So, we are updating maximum as 1 and indices as 0, 0. Next, what would be the next element in this J loop? So now I would be here, but J would be here, right? So the current sum would be this plus whatever the sum that is present till now plus the current element. So that's what we are doing, current sum. plus the array of j, that is the element that we are adding, which would be in this case it's 1. So is the current sum greater than max sum? Yeah, obviously 1 is greater than max sum, which is minus 1 at the moment. So now max sum will become 1. And what is the start index? See, just be careful. We need to say, as I mentioned before, I maintains the starting index. So I would be the starting index, and whatever the new j, that would be the ending index. So this is the starting index, this is the ending index. Likewise, we will check all the subarrays and find sums and see if the sum is greater than the global sum. And if it is, we will update it and return back. Right. So, but it will not stop till it visits all possible subarrays. So it will come till I being 4 and j being 4. That is 5. Okay. Till here it will come and it will check whether this sum is greater than the maximum and find the solution. So finally, if you see maximum and start index and end index, we will have which are the maximum values that are possible with all the possible subarrays. So this is the, you know, brute force solution. So brute force solution in this case is nothing but just finding all the subarrays and finding sum of each. And if this sum is greater than maximum, then we would obviously update the maximum and update the start and end index also. Okay. So now in this case, what is the time complexity and space complexity? See, this is a new variable that I am declaring and assigning it to certain number, right? So it is O of 1 assignment, and this is also assigning to variables. So first we are starting with the time complexity. I assume you guys have good idea on what big O of 1 or big O of n means. So it's just the worst case time complexity, okay? So it takes what unit amount of time to assign variables. Next, this for loop, we know it will loop through entire array, right? Because it has a range and it will not break in between also. So it would be O of n only if there is one for loop. But here in this case, it loops the array which has n elements. So what's the time complexity to only loop one array? It's n. But in this case, there is a child for loop, which is for each index of parent for loop. It again loops whatever to the right side of that parent index. So for example, I is here, it will visit this element, it will visit this element, it will visit this. So in worst case, how many elements it will visit? It will visit n, right? So for n cases in I, we will be visiting n elements. So what would be the time complexity of n square? So this is the rough calculation. Okay, if you want to calculate exactly, let us start from this case. So for when I is equal to 0, j goes to how many indices? It's like j will start from I, it will start from here and it will go to right side, right? So it will also visit n. So it will start with, for I is equal to 0, we have n values that needs to be visited by j, then n minus 1, then it visits one value at the end. If you sum this, it's nothing but n into n plus 1 by 2. Okay, that is n square by 2 plus 1. So if you want to find O of big O, it's just O of n square, because you will ignore constant values as well as any constant multiplicators. Okay, so what is the time complexity? It's O of n square. As you know, it's a quadratic form. So if you are increasing your input levels, the time it takes to run this particular algorithm would be too much. Like there is no way it can handle, for example, arrays that contain 1 million items. Okay. Coming to space complexity, it's nothing but how much space requirements we are taking into account. For example, here when we are assigning to a single variable that is also a single value, so it's just assume it's a constant complexity. Okay. If you, for example, if you need to assign a new variable which is an array, which is a copy of this solution, not solution, which is the input array, then you are declaring an array which is equal to whatever input array that they are giving. So how much space you require, n elements are present, right? So we'll say space complexity would be O of n in this case. Okay. Now, is there any array that we are showing here? No. Everywhere you can see we are having variables with a single values that we are assigning to them. Here, for example, we are assigning arrays value, one element in this array as a value to this. So it's just two of one. Okay. So this is something called as in situ calculation. Okay. So in situ calculation means what? We are using the array that is provided in the solution, sorry, in the question, and doing operations on the array itself. Okay, wherever we are doing the operations, we are accessing that array and elements in that array and storing them. So this is the brute force solution, which is bad. Okay, if you are only giving brute force solution to the interviewer as an answer, he'll say, "Is there any better way?" If you don't find the better way, you are not going to get selected. Okay, so be careful. And generally, brute force solutions are also the first solution you arrive at. This is not always the case, but this is generally what happens. So now, is there any better solution other than the brute force solution? Yes, obviously there is a better solution. So it's something called as Kadane's algorithm. Okay. So let us just not directly go into algorithm what it is. Let us try to see what we can do about our array. So assume there is an array 1, 3, minus 3, 6. So this is our array. So if I want to do something other than brute force solution where I'll try to find all the subarrays, let us just explore how we can do it. So let us start from first index, obviously, because we need to at least visit every index once to get all the information required. So with this understanding, we can say there would be no algorithm better than often. So this can be an interview question where they might ask, is there any possible solution with less than often time complexity? No, there cannot be something which is less than often for this particular problem. Okay. Now, coming into this case, I need to maintain certain variables, right? So let us, similar to you know, the brute force solution, we will be maintaining maximum and index for this maximum, that is start, next end index. So this is for maximum values. Okay. And so these are the kind of global values where we'll be having the what is the maximum that we found till now, what is the start index for that subarray and end index for that subarray. Now, let us maintain some variables to capture current state. Okay, so it would be current start index. Similarly, current end index and something like current sum. Okay, so these are the variables I'm planning to maintain because this will give me the basic information. So any kind of, mostly array problems or some other kind of problems, you will most probably declare these kind of variables. One is to maintain the current state, which generally gets updated in the loop. And one is to have a global state, which is outside loop and maintains like what's the best solution we found till now. Now, first, what would be my base case? I would have already visited first index. So what would be the maximum one? Start index would be 0, end index would be 0, current start would be 0, current end would be 0. What is the current sum? It's just 1, right? 1. So this is already fixed. So we can initialize these variables outside the loop itself. So now we will start our loop from first index. So that is here. So this is a positive number. So in this particular question, whenever I find positive number, I'm very happy. Okay. So what is the current start index? Is still 0, right? I have started there only. I have not updated it. What is the current end index? It would be 1. Okay. What is the current sum? 1 plus 3. It would be 4. Now, based on the current state, I need to update my global state, right? So first, I need to check whether this current state is better than the global state. So current sum is 4. Is it greater than maximum? Yes, obviously. So I will replace my maximum with the current value. And what would be the start index? It's again 0. What would be the end index? It's the current end index, right? That this is where I found my maximum. So it would be 1. Okay, I'm done here. Next case. I'll be going here. Now, what happens? Oh my god. So this is a negative value, right? So I know this will negatively affect my sum. But we cannot stop here because there might be cases, especially for example, in this particular situation, where larger numbers would be on the right side of this. So sometimes people say, right, when you do tough things or you face difficulties, you will get better prizes or better results. So our better things are on the right side. So we need to cross this. So now let us see this particular case. What would be the current start index? It's still this. Current end index, it's still this. But now I'm getting doubtful. So should I be including this, like including this in the subarray and taking this as a whole subarray or not? Now, if you calculate the running sum, how much is it? 4 minus 3, which is 1. Obviously, current end index has been updated to 2. Start index is same. Now I got the current state and I'll be comparing that with my maximum sum. No, it's very bad. So maximum sum will not be updated. So now just blindly go to the next index from whatever algorithm that we have developed our own. We will be going here. Okay. Now what will be the current sum? 1 plus 6, that is 7. What is the current index? 3. Right? So this is the third index. Did I change my start index? No. Right. What so if I compare my current state with the max state, max is 4 now. So my current state is 7. So is it better or not? It's better, right? So I'll update my max sum, which is 7. What is the start index? It's the current index. What is the current index? 3. So I need to update my max sum index also to 3. So this is the array which might give me the max sum. So it's like entire array. So if you eyeball it, is there any better way? For example, if I am taking only these 3, this will get cancelled, and I will get what 6 only, not 7. If I'm only taking these 3, I'm only getting 4. If I'm only taking 6, it's 6. So our algorithm has found the solution. I'm very happy. I didn't know what to do, but I've started one after the other and maintained the same variables that I have used in somewhat similar variables that I used in brute force solution. But there is an issue here. Consider this case. This is minus 5. Okay. So assume this is minus 5. What happens to our algorithm? So we are initially starting from here and coming here. By the time I am here, my maximum would have been 4, but my minus 5 would have caused the current sum to minus 1. Right? 1 plus 3 minus 5, that is minus 1. and I would not have updated my maximum. It would have been still 4. Now I'll be coming here 6. My current sum would be what? Minus 1 plus 6, that is 5. That is greater than by maximum, which is 4. So I would have updated maximum to 5 and said key this is the array, that subarray that has the maximum sum. But answer is wrong, obviously, because if you take this subarray, like for example, only this number, it's itself is larger than 5, right? So why didn't the solution be 6? So this is where we forgot. So we need to be updating our start index if we find something really good, which is better than the running and like running sum that we are maintaining till now. So for example, at this case, what would have been running sum? Minus 1, right? And if I have added that to 6, it would have been 5. So the sum till now would have been 5. But my current value, so current value, which is 6, is greater than this sum, right? So running sum plus current index. So my loop, my subarray which started from here, which has a running sum of minus 1, I have included this particular element 6 in that subarray only, but my sum has been reduced to 5. So it's better if I update my start index. Where is this? Current start index, to now forget this part. Why? Because this is not positively contributing to my sum. This entire current sum was minus 1. So instead of adding that minus 1 to 6, why not start our subarray here itself? Right. So that's where I'll update my start index to 3. And also at the same case, I will also check whether my maximum, this is not the maximum. Okay, this is for previous that we are doing. So which is here in this case it would have been 4, right? So maximum would have been 4. So we have updated maximum because our current subarray, which is just 6, with start index 3 and end index 3, is greater than maximum. So we will update this 4 to 6. And I will update the start index also, which starts with 3 and ends with. So my solution would be this. Maximum would be 6. My index would be start and end index would be 3, 3. That means this is the subarray that I will get the answer from. So now you understand, right? I can start like writing the, possible solution by declaring variables without any code. And the only way we can find our solution is wrong is working with some small examples and taking like lot of cases, whether this particular case will cover this or not. So I thought I have found the answer, but later I found for this case my answer is wrong. So our answer would be structured in such a way. First we will have a check, which is running sum plus current sum. So running plus current index, how it's compared to current one. If it's my current element is greater than this value, I'll obviously start from here only. I'll forget my history. Sorry, I'm not saying ki forget your history. Okay, history is very important to remember. But in this case, we will forget the whatever the running history that we have maintained. So if this is the case, then we will update the start indices. Okay, and we will find new subarrays other than the one we are coming up from the starting itself. Okay, so initially we'll have this check and we will update our variables. Then we will calculate current sum also. Then we will have comparison of current sum with max sum. If current sum is greater than max sum, we will solve the or update the max sum. So this is how easy it is. Okay, you don't need to, read theories or go directly to the solution and see what the code is doing. You can, get this algorithm without even studying this algorithm. Okay, but let us see the code for this algorithm. So I will just, discuss the important points. So what is this doing? This is maintaining the variables that are max ending here is nothing but the current sum. Max so far is the what are the sum that was max so far, which is global sum or maximum found till now. I'm initializing it with, let us take this array 2 minus 4 6. Okay, and initializing with the starting value. We are doing the same with start index and end index, which are in this case the global ones, which are representing the max found so far. Okay, these are not current values. So this current start index is the index for the current values. Okay, so everything we have started with 0, and we have seen in the example that I have just shown, right? We have initialized that with 1. So max ending, what's the current sum? It's 1. What is the max sum? It's 1 because it's the starting one. Then we have a for loop which starts from here. Okay, it doesn't start from here because our base case has already covered the 0 values or 0th index ones. So first, this is the check that I mentioned to change the start index. Like for example, if I should ignore my past values and start my index, like for example in this case, right? 6 itself is better than including all these values. So to update the start index from here to here, I'm checking if my current value is greater than whatever the running sum that I'm maintaining plus the current value. For example, here running sum is minus 1 till here. My plus current value, which is 5, which is less than a value itself. So it's better if we start our array from here or subarray. So I'm saying if this is the case, I will be updating max ending here. So my max ending would be here, right? So this would be where my max ending would be. And current start index, my current start index, which used to be here, now will be starting from here. So if this is not the case, for example, here in that case, right? For example, after 1, we are visiting 2. So there we want 2 in our subarray. So then we will be coming to this particular else condition. Then what we will do? What's the max ending here? That means running sum. What is the running sum? 1, that is element. Sorry, max ending, whatever that is present till now, that is 1 plus array of I, that is the current element. So 1 plus 2, that is 3. And updating that we have already done, right? Now we have checked all the conditions to update the starting indices. If that is not the case, we have calculated the run, max ending here, which is the running sum here in this case. Now, once it is done, we'll be going if to check. We have always checked, right? If my max sum comparison with current sum, and if current sum is greater than max sum, then we will update the max sum. So that's what we are doing. If max ending here, that means current sum is greater than max so far, like whatever we have found till now, then max so far will be max ending here, that is the current sum. And what would be the start index? That is the current start index. Whatever the subarray we are taking now, that is the subarray that we are updating the max value with, right? So that max starting index should also be updated with the current starting index because this is the subarray that we are taking for max index. Now, end index would be obviously this number. Wherever we are at the moment, that's where the max index would be ending, or even for example, in this case, the current index will be. So we will be updating and returning that. So don't, think so much in terms of actual code. It's always better to solve the problem manually, like we have solved for this algorithm before showing this code. And once that is done, if you are able to write the code, it is great. And if you are not able to code, if, for example, as I'm sharing this PDF with you, you can directly see the solution and you can easily understand because you can see this section is for our edge case that we found at the end. Here our algorithm is not working, and this is for updating the max values. So that is how you solve this problem. Okay. But I have now till now explained what one is brute force solution and another is this best case, that is Kadane's algorithm. There is one more solution. It's not the best case, not the worst case. Okay. There's something called as divide and conquer approach. So I am not gonna go through this particular approach for this problem. We'll be seeing this particular approach in future problems. But this is the problem that you can try on your own. For example, some people who are seeing this video might already have idea on this particular approach. So just I'll be giving you brief overview. What this approach does is it's like very standard approach for multiple problems. So this is an array, right? Now what I'm doing, for example, for example, this case, brute force case, what I'm doing, I'm finding all possible subarrays, right? Why not take only, half this array and half of this array? For example, in this case, for example, I will take, let us add one more element. So assume this is a middle element. Okay. I will send this middle array till this middle element to certain function, and again send this array from here to here to certain other function. So it would be same function, okay? Because this uh, same function will take left index and right index and try to solve the problem. Again, that will again divide this array into two halves. So simply the goal is to write an approach where we have a function. What it should do is it divide the entire problem that we have array into sub problems. For example, in this case, I am dividing them into two halves, and again, those two halves will be halved. Okay, and find, because it is very easy to find solutions in case of smaller cases. So solving smaller cases would be much easier. So once I find the solution for my smaller cases, what I'll do using those, I'll find the solution for my larger case. Okay. So it's called divide and conquer approach. Why? We are dividing our solution or our problem into smaller problems and solving them. And again, using those results, we are trying to conquer the entire. So this is just in an overview. There are a lot of things that you need to take into consideration. But if anyone wants to try this approach for this problem, you can try and give me the solution in comment section. I have also provided the solution for this approach in PDF that I'm going to share. So you can also go through that. But I'm saying it's always better to try for yourself, and give some time, for example, 1 hour or 2 hours. And then if you are not able to find the solution, just please look into the PDF I have provided. So at the end, for every day, I mean, for every problem, I'm going to provide you some ask yourself questions, which covers like every, aspect for this particular problem. So if you are able to answer these questions, so there are 10 questions here, right? So if you are able to provide answer to all these questions, you are well aware of everything that is required for this particular problem. So for example, this question, is it possible to have multiple non-contiguous maximum subarrays in a single array? See, till now, what we are taking into consideration, we are taking subarrays which are contiguous, right? So I'm taking 1, 2, 3, or 2, 3, 4, or only 4 itself. What if the question says find any kind of subarray? I mean non-contiguous subarray, which is 1, 3, 4 can also be a solution. That means you don't need to include everything that comes after one another. Okay. So it will be non-contiguous problem where solution might be first element, third element, and some other element. You don't need to be taking this entire stretch from here to here. Okay. So you can solve this, see that particular case in this particular ask yourself question. So these questions are very important. Give a lot of time to get the answers for this. I'm not providing answers directly because these questions will take certain time, and they provide a lot of insights when you're trying to solve them. So if you see the answer directly, you wouldn't understand the depth that is required to solve these questions. Okay. Yeah, so that's it from my side today. So if you have found this particular lecture helpful, please do like and subscribe and share it with your friends. And as mentioned, I have attached this entire PDF that I've used for this lecture in the description so that you can download. Okay. Thanks. Have a good day.